All right, guys, welcome to this page of the notes, and here's what we're going to do. We're going to continue with this theme of using the method of completing the square to solve a quadratic, but admittedly, up until this point, all of the problems we've done, we've really sort of gotten these nice, neat answers, right? Integers. They're either positive or negative. And guys, rarely in math does it work out that way. You're going to get some answers that look pretty odd. They're a little weird looking. And actually, they're the kind of answers that you look at and go, wow, I must have screwed up, because that's not nice at all. So for the rest of the notes, we're actually going to look at how do you solve these problems, these quadratics, by completing the square when your answers don't really come out quite so nice. And here's a perfect example. I've given you some decimals. So we're just going to chug our way through this one and see what happens. Now, fortunately, I've already put the negative 8.6 on the other side, so I've got the x squared minus the 5.3x, and I've left you the space to add your b squared over 4. So let's just go ahead and do it. X squared minus 5.3x. I'm going to add b squared over 4. It's going to be equal to a negative 8.6. Actually, I apologize. Sorry, this one's got a typo in it. That needs to be a positive 8.6. I am so sorry. Sorry. That needs to be a positive 8.6. That's my fault, I just fat fingered it when I was making the notes. So positive 8.6, and then you've got to add b squared over 4, right? Algebra says whatever you do to one side, you got to do to both sides. All right, here we go. Again, don't fat finger something on your calculator, but your b is a negative 5.3. So you'll do a negative 5.3 squared. You'll divide by 4. Keep all the integers. It is a rational number, so it's going to be a decimal, but it's going to be a decimal that ends. And in our case, it looks like it's going to be 7.0225. Plus 7.0225. This is b squared over 4. Do a negative 5.3, you square it, divide it by 4, and that's what you should get. We add it to both sides. This is now a perfect square trinomial. If you take the square root, right, of 7.0225, here I'll show you in just a second, right, it's going to be binomials. I add 8.6 plus 7.0225, and I wind up with 15.6225. I'm going to have an x and an x, and again, I need two numbers that multiply together to get me 7.0225, and they would sum to give me a negative 5.3. All you got to do is take the square root of this number, in which case you would get 2.65, but it needs to be a negative 2.65 and a negative 2.65. And again, I'm not really showing you how to do this because you just use your calculator to do it. Take the square root, 7.0225, 2.65, well, sorry, a negative 2.65 times a negative 2.65 is 7.0025, and you add those together and you get negative 5.3. So anyway, there they are. Take the square root of both sides. Don't forget to do plus or minus. Add the 2.65 to the other side. And you get an answer that's not so nice looking. And of course, you could, I did it in decimals. You could certainly convert it to fractions if you wanted to. In fact, the exact same answer, right? The exact same answer, but rather than in decimal form, in fraction form would be 53/20 plus or minus 6,249 divided by 400, square root of all that. These are the same. But in either case, not the nice, neat answers that we were getting in the previous problems. In fact, these ones are kind of ugly. Like I said, they're the kind of answers you look at and go, wow, I must have screwed something up. You didn't screw anything up, and I apologize, I shouldn't say ugly. All numbers are beautiful, even the ugly ones. Sorry, shouldn't make fun of numbers. But yeah, it's totally possible that you wind up with answers that look like this. So don't freak out. If you get something that looks like this, it's going to happen. It's going to happen. Let's take a look at a couple more where you wind up with an answer that looks like that. Like this one. All right, so right away we see fractions, but again, this is Algebra 2. We're going to deal with fractions, so just get used to it. There's going to be a lot of them. And this 11/5, neither 11 nor 5 are a perfect square, so I know it's no good. We'll just add it to the other side and make this sucker happen. We can do it. We can do it. Here we go. X squared minus 1/5 x is equal to 11/5. We're going to add b squared over 5 to both sides. Because algebra says whatever you do to one side, you got to do to both sides. Again, don't fat finger something on your calculator, but negative 1/5 goes in for b. So you do a negative 1/5 squared, and then you would, oh wow, oh my gosh. How about a 4? Don't let me do crazy stuff like that. So you're going to plug a negative 1/5 in for b. You're going to square it, and then you're going to divide by 4, and when you do that, you should wind up with something that reduces to 1/100. And here's the reason why. 1 squared is 1, 25 squared, or I'm sorry, 5 squared is 25. It drops into the bottom, and 25 times 4 would be 100. So you wind up with 1. 1/100. Okay. I know it looks ugly, but it is a perfect square trinomial. So it's going to be x and x. And again, feel free to FOIL it out when you get done to prove it to yourself. But I need two numbers that are identical. They both have to be negative. 1 times 1, of course, gets me 1, and 10 times 10, of course, gets me 100. So I'm going to subtract 1/10 and subtract 1/10. And then I'm going to have 11/5 plus 1/100 is going to be 2/21/100. Again, remember, in order to add fractions, you need a common denominator. Of course, our common denominator is going to be 100, or you can just use your calculator. Just use your calculator. 221/100. This is going to get me, let's see here. Take the square root of both sides, plus or minus the square root, 221/100. 221, not a perfect square, right? 221 is not a perfect square, but 100 is. And hopefully you guys remember that property of square roots, where if you have division inside the radical, you can split it up. Take the square root of the top, you can take the square root of the bottom. That's exactly what we're going to do. Let me move over here so I have a little bit of space. I'm going to squeeze it in right over here. And I wind up with x is equal to a positive 1/10 plus or minus the square root of 221 all over 10. You could leave it like that, or you could write your answer, right? I have common denominators, so I would add the numerators, and I would have 1 plus or minus the square root of 221 all over 10. Whatever, both of those mean the exact same thing. I could give it to you either way on a test or a quiz. When it comes to that kind of stuff, I guess I don't really have a preference. Be comfortable with it in either form. But again, the point is, Not the nice, neat answers that we had been getting, but still a perfectly legitimate answer to this question. And remember, it represents x-intercepts. This is where your parabola is going to cross the x-axis. Your parabola is going to cross at 1/10 plus the square root of 221 over 10. It's going to cross at 1/10 minus the square root of 221 over 10, which of course you could find those in decimal form by simply putting them into your calculator if you wanted to. But remember, if you're taking this class with me, I will not give you decimals on the test or the quiz as an answer. I will leave them in radical form if it's not a perfect square. I got another one for you. Let's check out this one. See how it goes. All right. Negative 24/5. Moving to the other side. Add b squared over 4. Here we go. My b is a negative 9/2. We can do this in our head. This is good mental math. A negative 9 squared would be a positive 81. 2 squared would be a 4. The 4 gets dropped into the bottom, and so I wind up with 81/16. And 81/16 I don't believe reduces, so you're going to wind up with x squared minus 9/2 x plus 81/16 is equal to 24/5 plus 81/16. Okay, in order to add 24/5 plus 81/16, you need a common denominator, which would be the LCM of 5 and 16, the least common multiple of 5 and 16, or you could just use your calculator. And if you just use your calculator, you're going to wind up with 789 over 80. And then I need two numbers that multiply together to get me 81 over 16, which of course would be 9/4. A minus 9/4, right? It's got to be minus because this number is negative. So a minus 9/4 and a minus 9/4, which is going to be okay. We're going to take the square root of both sides. Don't forget your plus or minus. 789 all over 80. Okay, yeah. So let's see what happens here. I gotta add, slide up a little bit. I gotta add that 9/4 to the other side so that I have x equals 9/4, a plus or minus. We're gonna split these guys up. We're gonna do the square root of 789 over the square root of 80. Yikes. Let's do 16 and 5. Why? Well, because 16 times 5 gets me 80, and the square root of 16 is 4. And there you go. Pretty sure that's as simplified as it gets. I don't believe 789. Hang on, let me grab my calculator just to make sure. But I'm fairly certain that 789 is not going to be divisible by our perfect squares. Nope, that's it. That's as far as you can go right there. It's going to be your answer, 9/4 plus the square root of 789 divided by 4 times the square root of 5, or 9/4 minus the square root of 789 divided by 4 times the square root of 5. Those are your two roots, x-intercepts. That's where your parabola is going to cross the x-axis. Guys, thanks so much for joining me on this page of the notes. On the next page of notes, we'll take a look at a few more problems where the answers get a little wonky on us when it comes to completing the square. So head on over to the next page, and I'll meet you guys there.